So here's what I expected most of you probably drew something like this. And it was kind of a trick question. I kind of set you up to fail because I wanted you to think about it. And if you want to, you can think about it again as soon as I'm done with my explanation. But these two drawings are the exact same thing. So when we go and look at a drawing of a hydrocarbon, it's basically how are the carbons connected. That determines the structural formula. So even though I drew it in a way that it came down, the fact is you have a carbon 1 connected to carbon 2, connected to carbon 3, which is connected to carbon 4. That's no different than carbon 1 being connected to carbon 2, being connected to carbon 3, and then carbon 4, even though it's drawn this way. I mean, just because you drew it a certain way doesn't change the way that the molecules and the atoms are connected. And that's the main key. So if you want to take a second, pause this video, and try it again, go right ahead. But the real way to actually draw the isomer of a butane, because there is only one, is interesting. So if I draw 3 carbons, I'm just going to start with 3. 1, 2, 3. No matter where I put another carbon here, up, down, or left, it's going to be the exact same thing as this, which is the exact same thing as this. Well, what if I put it over here going up? Again, it's the same thing. It's 4 carbons connected in a row. The only way to draw butane in a separate way is to draw off the middle carbon like that. Because now, instead of having 1 carbon connected to another, connected to another, connected to another, we have 1 carbon connected to another, and this carbon is connected to 2 carbons. And it changes all of the properties about it. It could go from being a gas to being a liquid. It could go from being poisonous to not poisonous. It could change everything. So again, the last step here, though, would be to put in the hydrogens and make sure we got 10. And we'd put 3 here because there's only 1 bond on this carbon. We'd put 3 here because there's only 1 bond to this carbon. We'd put 3 here because there's only 1 bond to that carbon. And here, this carbon, 1, 2, 3, would only receive 1 H. And by counting all of those up, you would get C4H10, which is an isomer of that. So now I'm going to show you, now that you have the understanding of how isomers are created, I'm going to take some of these more confusing names and we're going to draw them. And this is going to help you understand why this and this are not butane. And this are not butane because they have different names. We're going to get to naming later. But for now, what was that? We have to understand that this part has to be specifically named. All right. So on your sheet, you have 3 examples that I'm going to walk you through. And this one's called 2-methylbutane, 3-ethylhexane, and 2,4-dimethylheptane. It sounds like a lot, and it isn't, but it just understanding it and getting the basics will really, it'll be easy once you get a hold of it. But my first thing, the way I always teach this, is to work backwards. We draw the longest carbon chain. Now, on the notes that I gave you, it says last word or something in the name that's given. And so what I really mean by this first step is if this thing is called 2-methylbutane, this is the last word. This is the longest chain. This is what I like to also call the backbone. The backbone of the molecule is based all off of a butane molecule. So I'm going to draw that. We already know how to draw it. That's what we practiced up there. A butane has a prefix of but, which means it's got 4 carbons. It has a suffix of ane, which means it's all single bonds, and that's a pretty simple thing for us to draw. So 1, 2, 3, 4. I'm not going to touch the hydrogens yet because that's always the last thing I do, and I think that's on your sheet. It says number 3, add hydrogens to end. But here's where it comes. We're going to draw the branches. Branches are things that end in YL. then those things are coming off the carbon chain. So it's not like we're drawing this separately. We're drawing this on the backbone that we already created. The number indicates which carbon it branches off of, and that's something new, and it's really easy because it's basically like each one of these carbons has a number. It has a home, an address. This would be the first carbon, reading left to right. This is called carbon 1. Now, you don't have to write these numbers in. I'm just doing it for you. This would be the second carbon, the third carbon, and the fourth. So when every carbon is numbered, it becomes really easy to locate carbon 2, which is this guy. Once you've located carbon 2, then we read what the branch is telling us. And this is really no different than how we figured out that had a 4-carbon backbone. Meth is a prefix that is found on the same table as but, except for the fact that this doesn't mean 4, it means 1 carbon. The YL is the suffix. As I said here, YL is telling you it's a branch. It's not the backbone. It's a branch that comes off of this carbon chain. And so I would find the second carbon. The branch is a meth group, which means it's 1 extra carbon. And then you're done. Aside from adding all the H's. So a shortcut to adding H's is you don't actually have to draw the H. You can just do 1, 2, 3. A blank atom indicates a hydrogen. So it speeds it up. You can do it. You don't have to do it. It's up to you. Carbon down here has 1 bond, so it's going to get 3. Carbon right here has 3 bonds. It'll get a 4th hydrogen. Bop, bop. 1, 2. Bop. 1, 2, 3. And that would be how you would draw 2-methyl butane. So what it really is saying, if you were going to read it as we drew it, reading it forward but kind of circling around this word, is we have a butane chain, and at the second carbon there is a meth, or a 1-carbon branch. We have a 4-carbon chain, and at the second carbon there is a 1-carbon branch. And that's how you draw it. And this right here is called 2-methyl butane. So we'll do this one. Move a little bit quicker. 3-ethyl hexane. Backbone, last word, hexane. 1, 2, 3, 4, 5, 6. Hex, prefix means 6. Ane means they're all single bonds. So that is my backbone. Although I drew a 6 instead of a C. 1, 2, 3, 4, 5, 6. All right. After this, I don't want to add my hydrogens because I have this branch to deal with. And basically it tells me that at the third carbon, there is this branch. I'll get to the branch in a second, but I got to find the third carbon. 1, 2, 3. Carbon number 3. What am I going to put at carbon 3? An Eth branch. I go to table P. Eth, not meth, is a 2-carbon branch. YL tells me that it's a branch, which means it comes off of my main 6. In addition to my main 6, I add 2 extras. 1, 2, 3. Third carbon. 2 carbons in addition to what's already there. And then the checking thing, did I draw the 6 carbons? Yes. Did I go to the third carbon and draw 2? Yes. I'm done. Except for adding my H's. 1, 2, 3 there. 1, 2 there. 1 here. 1, 2 here. 1, 2, 1, 2, 3. 1, 2. 1, 2, 3. 3-ethyl hexane. All right. Now the last one has got a little bit of a catch to it. It's called 2,4-dimethyl heptane. This is going to confuse or frustrate some of you, but this is another thing that the Regents does that, well, it's not the Regents, it's science. It is the chemistry, the naming of this stuff. But this is really redundant. dimethyl, trimethyl, it's redundant because what it's telling you is that you have two branches. It's saying I have two methyl branches. But the way I, say it is I know I have two methyl branches because I have two numbers. And it's kind of telling you, like, however many numbers there are tells you how many branches you're given. So seeing that there are two numbers, there's going to be two branches. So I already know di that I have two methyl branches. So here I go. Heptane. Heptane is a 7-carbon chain. I'm going to do it over here. Try and do it a little smaller. 1, 2, 3, 4, 5, 6, 7. I'm just drawing it on a slant so I can fit it on the page. At the second carbon, I can put a meth group. And at the fourth carbon, I'm also going to put a meth group. I'm going to put two separate meth groups at two separate places. So there's a meth group here. 1, 2. Boop, boop. There's also a meth group here. Now, one of the questions people ask, and you're going to ask, well, can I draw it like this? Yes. Okay, well, can I draw it like this? Yes. It doesn't matter where they're pointed, up or down. The fact is, if the methyl group is on the 2 and the methyl group is on the 4, then it's done correctly. 1 up, 1 down, 2 up, 2 down. It doesn't matter. So 3 here, 1 here, 2 here, 1, 2, 2, and 3. And that right there is 2,4-dimethyl-heptane. So I'm going to task you with a sheet that is going to have you practice this. And I'm actually going to post a video of me just much more quickly and rapidly showing you how the solutions are what they are. And I'm also going to post a Regents question set. Okay, and this is going to have answers explained to you as well. And finally, there'll be a quick little castle, a few questions just to make sure that you're really, and that I know that you're getting it. Because that's kind of the point of the castles, is to make sure that I feel comfortable progressing because you're understanding. So definitely do me a favor and give me a private message or whatever it is, the comment on this assignment on how this lesson with the videos worked better than the just reading it. I have a feeling I know what most of you are going to say, but I still would like to know. And that's my little Stella when she was a baby. Bye.